So good afternoon, ladies and gentlemen. Today we're going to be taking a look at finding the rules of some functions that look like this. Now clearly this is not a sinusoidal function, which means we can't use a function rule that has a sine or a cos in it. But we do realize that it is periodic, and the only other one that we're learning about that we haven't yet seen is f of x is equal to a tan of b x minus h plus k. So today we're going to look at the tangential function and finding its rule. Now when you're looking at the tangential function, one of the first things you want to take a look at is the points of inflection. And the points of inflection are most easily found by looking at the center of your asymptote. So if you'll notice here, right in front of me on the board, we have 4 different asymptotes. They're denoted by these vertically dotted lines. Okay, and we have some points of inflection which occur right in the middle of those. So right in between 1 and 5, we'll find one point of inflection, and that occurs right here. Or we have another one between 5 and 9 that occurs right here, and there's another one that we can see clearly, which is right there. So these are the points of inflection. Those are the starting points of our tangential functions, and those actually correspond to our hk values. Now you can choose any one you like, it doesn't matter which, but most oftentimes people will choose the ones that are closest to the y-axis. So in this particular case, we're going to use the first inflection point. I'm going to denote it in green here. This is the one we're going to use as our h and k value. So this value here is going to be at -1, comma, -1. But you could very easily choose any one of the other ones, and it doesn't matter. So the first thing we're going to do now is write down our function rule as defined with the h and k that we just used. So we're going to write this down as f of x is equal to a tan of b x minus -1, so that's x plus 1 minus 1. And now what we have left to do is find the value of a and find the value of b. Now, unlike the sinusoidal functions, you don't just use an amplitude here, because when you're talking about a tangential function, it's not bound between any two values, so you can't be talking about an amplitude for the tangential function. There still is a periodic repetition here, and you can notice that it repeats every 4 values. And for the tangential function, the b parameter was defined as plus or minus pi over the period. Okay, so it's not 2 pi over the period for the tangential function, it is pi over the period. So for us, we have b is equal to plus or minus pi over 4, because our period here is 4. Again, we get to choose whether we want it to be plus or minus, and it doesn't really matter because it's going to affect our parameter either way, and we're going to be able to come up with a function rule no matter what sign we choose for the parameter b. So if we choose a positive, because most people will prefer to use positive, so we'll just follow that convention, we're then going to deal with a function rule that looks like f of x is equal to a tan of pi over 4, positive pi over 4, times x plus 1 minus 1. Okay, now here's where the difference lies between the sinusoidal function and the tangential functions, is that we actually need to use a secondary point that is not one of those inflection points to plug in and actually solve for the value of a. So the one that we have here on the board, which I'll denote in red, so I'll highlight it for you right here, this is at -2, 1. And so we'll use those coordinates and plug them in to the tangential function, and we'll solve for the value of a. And so by that I mean, if we just follow that up here, we're going to write our function rule, and we're going to replace f of x and x according to -1 and -2, 1. So that will be rewritten as 1 is equal to a tan of pi over 4 times -2 plus 1, so plus 1 minus 1. And now everything is defined. The value of 1 and -2 came from that x comma f of x that's up on our graph. And now we'll find here that 1 is equal to a times the tan of pi over 4 times -1 minus 1. And so we can start to isolate off for our a here, and we'll have that 2 is equal to a times the tan of -pi over 4. Okay, so 2 is equal to a times tan of -pi over 4. And using our standard unit circle, we know that the tan of -pi over 4 is -1. So here we have 2 is equal to a times -1. And that's just coming from evaluating the tan of -pi over 4 using our unit circle. So if we have that 2 is equal to -a, then that must mean that a is equal to -2. And now we have everything that we need to find the function rule for our tan function that we have here on the board. So we'll just rewrite our function as f of x is equal to -2 tan of pi over 4 times x plus 1 minus 1. And that's how you find the rule of a tangential function.